Hello and welcome to Tag1 Team Talks, the podcast and blog of Tag1 Consulting. Today, we're going to be talking more about finding and fixing problems with Goose, an open source load testing framework that was inspired by Locust and written in Rust. It's the most scalable framework available. It is the easiest to scale. You can check out all of our talks on Goose at tag1.com/Goose. Today's talk is a really great example of why you should do load tests over long periods of time and not just short runs, as well as why you should be performing edit actions on, creating content and performing editing actions on the content that you create. During our last talk on Goose, we explored the practical side to load testing, and we walked through how to analyze your load testing results using New Relic so that you can find problems that are impacting your website and address them. We load tested against the Drupal framework and CMS with a default Umami install. And in the process, we did discover a problem. The problem is with Quick Edit. Quick Edit allows you to quickly edit your content without having to leave the context of the page and going into full edit mode. What we found in running a load test over a long period of time and creating and editing content is that when you have a lot of revisions, load times get insanely slow for end users. We're going to walk through how we use a local container to track down the bug, fixed it, and then confirm the fix with follow-up load tests. I'm Michael Meyers, the Managing Director of Tag1 Consulting, and joining me today are two performance and scalability experts, Jeremy Andrews, the founder and CEO of Tag1 and the original creator of Goose, and Fabian Franz, our VP of Technology, who's been a major contributor to Goose and a really well-known performance and scalability expert. Fabian is responsible for a lot of the performance and scalability in Drupal. Jeremy, Fabian, thank you guys so much for joining. I'm excited that we found a bug in our load test. Not that there is a bug, but that we set out to do a load test, and sure enough, we found one. And I thought, I learned so much in how to track things down with New Relic. It's this amazing tool. Fabian, could you tell us, just rewind a little bit, tell folks how we discovered the bug, what jumped out, and what the next steps were?
So essentially what we did on New Relic, we tested our beautiful Umami install and did that for quite a while. So we've run it for a few hours, both for testing the load test so that we had good numbers, and then later just to demonstrate it. And we found that over time it got slower. But we also found that we had several slow responses always there. Things like 27 seconds, and then we found that all those responses, especially when we looked at a partial trace in New Relic, we found this one function, Quick Edit Entity View Alter. So apparently Quick Edit did something here. So let me share my screen, and we're gonna start here. This is the Umami. I'm logged in as an admin, and just to show real quick what Quick Edit is, it's this. So I can just edit this and then save it if I want to, or I can discard my changes. That's Quick Edit in a nutshell. The bug we found actually is pretty well known. It's a regression from 2018, was created 17 March 2018, and it still needs work. It's still not fixed in Drupal 9.3x, and it's a critical part of the entity system. And here we can already see some people have already debugged something, but we are not going to look at that because when I start debugging, I didn't have that. So let's assume we don't. So the first thing I did was I ran a Goose load test against my Umami instance. But surprise, the problem that was so apparent on New Relic was just not to be found. So then I thought, maybe it's something that has to do, that just happens after a while. And so I did leave Goose running for a night and came back the next morning then, and voila, the problem was there. Then I looked at what has changed essentially, and what has changed is that whenever within a standard Umami profile an article is edited, you create a new revision of it. So here we have several revisions created by admin, which are created by the load test, and one originally as part of this profile. Okay, so it had something to do with revisions. That was a good point. So what I then did was I created kind of a little a shell script that was just duplicating one revision entry because I want to really exacerbate the problem. Turns out 100,000 revisions is way too much. We'll later see what's that about. But essentially, in the end, I want to have 500 revisions. So what we can do is we could count the number of revisions from an out revision group by node ID. So there we see many just have little ones. So this is no longer the installation where I did run Goose overnight, but this is a new installation where I then just input like around 6,000 revisions just to exacerbate the problem. So this is how the revision table looks. And then we can essentially start with two things. We can start from the code level and just look at what's calling quick edit, anti-view alter, what is that calling, what is that calling, what's that calling, and go there. Or we can, now that we control our local, essentially get a trace. And for that we start a normal load test, just like normal. So we have our Goose here, admin username, password is already in the environment, and we are just starting it up. And because I have so many revisions, Goose should be able to show me the problem. So while we're waiting for Goose to do that, I've also put us a little nice tool here into our installation. And we're using, for this whole installation here, we're using ddef. That means, again, for example, the ddef drush and execute drush commands on this installation, or I could quickly get a database connection via drush SQL CLI. So ddef is the core installation used. And but what we really would like is kind of like a local new Relic, so that we can essentially record all those runs that are doing. And this is what I did. I installed a tool called XH Graphical User Interface, and a little bit old but still working. It uses a MongoDB container, and it uses a web container to then show me all the recent runs. And here you can see whenever Goose is visiting a page, I am seeing here my my traces. So that's really, really nice. And despite New Relic, which obviously also needs to work with production instances, and we did test on a kind of production instance, our load test last time, we only get partial traces unless we configure it specially. Here I get full traces because I don't care as much about the performance, more about the relative performance. So we can already see, do we have something with the longest wait time? Yes, we have. So here we have one that took 22 seconds, 22 seconds, 90 seconds, 18 seconds, 17 seconds. Okay, so always the same article, funnily enough. Okay, so probably one that gets edited frequently. We could now look into one of those ones and see already, oh, it's something with the database that takes so long. The remainder is kind of not really. And you can see this graphical user interface is a lot more raw than New Relic in that, but we can still get a pretty nice idea. So there's two ways we can now essentially get to, oh, there's also some nice graphs, who's using what memory, etc. And I could essentially, I have two ways to go forward now. I can go to who's calling the statement wrapper execute and taking so long. Then I can look up to the query, can look up to the execute and go through that all. Or I can do something a little bit more smart, because I know this is just one function that is so hard. So I should be able to sort by it, in theory at least. But apparently I can't. Okay, then we need to go just click through. So we just need to always look at where's the largest result, and that doesn't take long. Parent function execute, again the parent function of that, and now we see this query function is not called by much. There's just this get default revision ID from content moderation, then there's this moderation state filed item, then there's get latest revision ID and get latest translation affected revision ID. Which is kind of interesting, but we see already our bugger is here, get latest revision ID. So and this is called by entity type is revisionable, and this takes very long apparently. Okay. So now we wanna look at and this is even called by this parent functions in certain contexts, but it can also be called itself. So this would be the view from internal. How do you get this nice graphical user interface on here? Right now, this is just a pull request in the DDEV contrib repository. It's a pull 128. And this is essentially has a nice recipe of how you can set it up. The first thing you need to do is in your DDEV config YAML file, you need to add this web image extra packages for XHProf. But I've been told that in future DDEV versions, XHProf will be available by default, similar to Xdebug. So that's a great win already for open source, because there's something else proprietary supported out of the box also. Then we copy several folders to our DDEV folder. Essentially, you just follow this recipe. And then for the application, I've used the WordPress way because somehow the Drupal way, the Composer way didn't work for me. So I just download this PHP profiler here and required both those files, and there was up and running. So let's take a look at how this looks. This is essentially just 2 lines of code added here, and that's it. By the way, I did the same mistake as we originally did with our new Relic thing. I didn't have Redis enabled first, so I quickly mitigate that by adding Redis here as well. We have the standard Pantheon information. Just because before it was kind of screwing up my database statistics because it was having way more load on the database than I ever expected. So I'm not going to do that. The other way how we could have landed
that
here.
settings.php, correct, that you were just looking at?
Pardon the question again?
That was settings.php you were looking at?
Yeah, this is settings.php. So we are looking at sites default settings.php. The standard settings PHP from Drupal. And this is just where I, just before DDEV includes its settings, I put this auto load here. I still hope that within DDEV itself we can do some little tricks of either using preload or adding it automatically to settings DDEV PHP if you do XHProf on and off, like that you can enable it by default. And then we can have some little helper script that is not the full-blown graphical user interface if all you want are some traces, essentially. But this is a great solution that works very well with Goose. Our Goose Attack is still running, as also printing statistics from time to time, but we've not yet seen the maximum. So I'm gonna stop this here now. And once Goose has stopped, we can clearly see here we have an anon request, and it took 23 seconds. So despite, in theory, this thing should only be affecting authenticate users because quick edit is only there. Apparently, we have traces where this is affecting anonymous users as well. So that's pretty interesting and makes that critical bug even more critical. This is something that Goose found. This didn't show up in the trace as clearly in in New Relic. When we are testing on Pantheon, not only local, we also have the CDN, which is pushing a lot of load off. So it wasn't as prevalent here, but Goose can clearly show us that the authenticated user here in this node call for posting the authentication, getting the authenticate edit form, there's all performance problems here. So this is really, really nice of Goose of showing us all this. And we can see that even that our average is still pretty okay for many things, but it's the maximum where we have the real problems, and Goose shows it directly. So if you hadn't a nice tool like Goose, how would you go ahead in doing this? So you would go to Quick Edit Empty View Alter, and you would need to know, and if I remember correctly, we even saw this as latest revision in the New Relic screenshot. So okay, we know it's this is latest revision. What's this latest revision even about? That was something I asked and even questioned Core about. Core has the idea of forward revisions. So you have a published revision, and any revision created afterwards is a so-called forward revision, which usually are drafts of the content, etc. But if you are in this mode and apparently you want to quick edit, you never want to edit the published version, but only the latest revision, essentially. Even if what you are seeing right now is the published version, because it hasn't been published yet. So this is all a little bit complicated, because Core, except if you use workspaces, which you really should, because then it's all clear of what belongs to what, because then if you change the workspace, well, it's clear you are editing in this workspace, and if you change to published, it's clear you are editing published. But here what would this edit, essentially? Would this edit the draft?
It's clear to me. What you just said was confusing. Are you saying that we're editing the currently published, or we're editing the not currently published right now?
The trick is, whenever we are looking at a live version, then this quick edit link does not want to show, because it would be confusing if you edit it and then it's a completely different title in the edit mode than in this.
So quick edit's only going to show up if you're showing the last even unpublished revision. Is that what you're saying?
Yes, if you're looking at the latest revision ID, essentially. Just then will the quick edit link show up. But there could be editors that can't access drafts or workflows or like that. They're only seeing like the live version. And so for those, this link just should not show up. So Core has this idea of a latest revision idea, which is essentially the latest draft. And the latest revision ID is essentially the maximum revision ID, at least if you don't put translation into the picture, because then it gets even more complicated. It's the maximum revision ID in the node revision table grouped by node ID. So in theory, it's as simple as this. It's not the count, but it's a maximum of BID. So here we see what the maximum revision ID is based on the node ID. Maybe we should put the node ID in between. So, and because I've created a lot of revisions once and deleted them, we have pretty high node IDs by now. But yeah, this is essentially what Core expects to do. So what we can also do is we can write a little test. Now that Goose is no longer here, we can write a little performance test of essentially just running this part. So what I like to do is I call it scr.php, and the reason is because I can just do ddf ssh Then I go to the directory where I have that, and then I do drush scr, which is short for script. And then I execute this little script, and I can even put a time before it. And after some time, we'll both be having a result of what the latest revision ID for node 16 is. And it's correct. It's certainly correct. We can see that here. But we can also see it took 12 seconds. And this run, nicely enough, is also showing up with the URL of slash. This could be improved a little bit of, like, for example, showing the command line parameters. If it's on the command line, we can see it took 12 seconds here. We can take a look at the run, and nicely enough, of course, it's database statement wrapper again, what's making the problem, and get latest revision ID as we already know. So yeah, so we found our troublemaker essentially. Now we need to find it in the code. Now that we've looked at it from all the stages. So such a script is very, very useful for testing this because you don't want to, especially with complex scenarios, you want to really just performance test this part that is so slow. You don't want to performance test everything essentially. So from quick edit, we would then we would go to its latest revision for the NT interface, find that either via IDE or via grabbing. Again, this is calling get latest revision ID here, and from there we go further to the content NT storage base where this get latest revision ID is implemented. And this is essentially an entity query, which is having the special latest revision part. And this is what introduced the problem, essentially. For the get latest translation affected revision ID, they have some other special key here, but they're essentially doing a range and they're doing a sort for the revision. And the reason for that is and using all revisions instead of latest revision. And the original quick edit code used this part as well. They also used this kind of sort, etc., and it was fast and it was nice. Just when Core introduced this generic interface, that is when things got really slow. And the reason for that we see in the last part where the actual query is, and we see there's a left join, a self join on the table, where we look at all the revisions being smaller and then being is null. And I've prepared that for us here. And again, we can see this takes like a long time, like 5 seconds here. And the reason why this is so slow, this kind of query is, and in this case, an explain doesn't even give us this information because it says using where, using index, not exists even, is because we cannot really optimize based on the idea that we have the node ID already. And essentially it grows quadratic based on the number of nodes and the number of revisions, because the self join on a table and then is null is performance wise not a good idea. But the problem is this max revision ID would also not work due to the fact that we really want to filter this whole query based on that. So the best compromise we came up with, essentially, instead of having all this left join, is to using instead just an inquiry. And then we select again the max VID from node revision. No limit needed. Okay. So, and I did a mistake here. Sorry. sorry, yeah. And this needs again to be grouped by node ID. And now we have our result. And our explain says that at least for not too many node IDs, now we are based on the number of node IDs, this view can even be materialized and using an index for group by, and that's already much, much better. It's using a complexity of the number of nodes, but it's no longer quadratic complexity. And that's really, really important. The problem is, this is still not making any use of the fact that we know the node ID. So essentially, if we give this information to the subquery, which we cannot generically do, sorry, not base table, that's not down here, then it can just use an index and doesn't even need to use group by anymore, because, well, there's only one NID, so it can essentially change this and then select tables optimized away. It's just a materialized query directly. So, and this is how essentially we solved this for the core issue. It's, let me quickly change to the branch. Or let's take a look at the diff. Probably easier. So what we're doing for gate lates to revision ID is essentially we put it back to what it was originally. We just get all revisions, we put a range of 0, 1 on it, and we sort by the revision ID in descending order. And that's fast, because that's what a database can very easily do. It's as similar as just doing a max. The other part is, instead of using this join, and this wasn't my idea, but someone else essentially had the idea that we add this as a subquery. So we essentially say the revision field should be in this max group by expression, which we just ran, essentially this group by NID. And this isn't optimal. It would be much better to have a nice mapping table which you could join for where core is always tracking the latest revision ID of any revision. But this is at least much better than we had before. Yeah. And this is not core patching in real time, but at least core explaining a core patch. And how we can use Goose to really help us streamline things, find performance problems, and yeah, even prove that this is not only affecting authenticate users but also anonymous users due to whatever. But this is Umami standard, so yeah.
Are you able to run the load test again with that same database, but with the patch applied, so we can see that it doesn't have that slowdown anymore?
That's a very good idea. Let's do that. Okay. We have the patch.
Setting that up. I mean, it's really impressive to me, and you know, makes me understand why we have such a great business. You know, you talk about how you ran that load test and you saw that there was a problem, but it took a tremendous amount of creative problem solving to actually find the problem. And then you need to know a ton about performance tuning code to fix the problem. So, you know, it's a pretty multi-layered challenge when you're load testing here.
Yes, it is. Performance tuning is not for the weak. It certainly is. It's not the problem is you never know if you find a problem, if you can fix it, what kind of structure you need, and with many of those parts, yeah, performance problems can be really tricky to find and exploit. But these are just tools that can help make it easier, etc. And then even core had the right idea, but there was feedback that this group by query wouldn't be better, and we need something much better. And so a good solution was delayed due to a perfect solution not yet being there. And that's also a little bit, and here you really need to understand, if you're still studying, study your big O's. They're so important to know if something is quadratic complexity or linear complexity. It makes a world of difference. So yeah, and hopefully this is fast now. So let's see what our longest wait time is. Yep. So longest wait time by now is 2.4 seconds. And we've been running already for quite a while. So we can assume this is fixed.
So then if you also cancel the Goose load test, you shouldn't see any of those really long.
Yep, probably.
You can also tell that into the controller and do metrics to not stop it if you want.
Yeah, sorry, exited already. But yeah, there's
very cool.
Normal max 23 seconds. And
is that pretty common, you know, this sort of pattern, you know, the complexity of finding, I'm sure it's hard to say, but is it like 50-50, 80-20? Like what percentage of the time is a problem like really obvious and easy to fix? And, you know,
most time you find a root cause at some point. The trickiest performance problems is if nothing is slow, but just the whole thing is slow because it's just, for example, too many layers deep. Then the best thing you can do is to add really nice caching. But if there's something that is really slow, then it usually can be fixed in some way or another.
Awesome. Well, Fabian, Jeremy, that was really cool. Thank you for walking us through that. For the folks listening, please be sure to check out our other Goose Talks at tag1.com/goose. We have lots of blog posts on how to use the tool, how to find performance problems, and how to fix it, like today's talk. If you have questions about Goose, please post them to the GitHub issue queues. If you like this talk, please remember to upvote, subscribe, and share it out. You can check out our other Tag1 talks at tag1.com/Tag1 Team Talks. And as always, we love your feedback on this episode, as well as topic ideas for future episodes. You can write to us at ttt@tag1.com. That's Tag1 Team Talks at tag1.com. Again, Fabian, thank you so much for joining us. Thank you to Pantheon for providing hardware to test these Drupal instances. And thank you to everyone who tuned in. Really appreciate you joining us.